All right. Happy Pluto Day. Okay? There weren't very many to choose from for today. Well, some people consider it a planet. Yeah. Yeah. Other people consider it a dwarf planet. Some people consider it just a hunk of rock floating out in space. Okay? So happy Pluto Day today. The other thing that we wanted to talk about here before we get into vectors in a plane is your second semester extra credit opportunity is Pi Day. Okay? Now, unfortunately, this year Pi Day is on a Saturday, so we will be celebrating Pi Day a day early on the 13th of March. Okay? We will allow you to make a pie and bring a pie in for consideration for extra credit. The 4 criteria that we use for extra credit on Pi Day is taste. So I have to taste all of your pies. And on that day, we will be doing nothing but eating pie. Quantity, meaning if you bring in a little teeny tiny one versus a regular sized pie. Creativity, and we actually will have to get rid of this one because last year we allowed store-bought pies, but we are not allowing store-bought pies this year. They have to be homemade. Okay? Albert, by the way, congratulations. Nice job last weekend.
Oh, thank you.
Oh, yeah. 8th place in the state right there. Downhill skiing. Or, sorry, alpine skiing. You want to. Okay, so we're going to re-up these, but it'll be worth up to 4 points of summative points. Okay? Right? So summative points due on that day. Okay? We will supply napkins, boats, and utensils to eat with. But yes, bring your pie in on Pi Day Eve for your consideration. Okay? Okay? Any questions on that? No store-bought pies. Okay? With that being said, I want to change up this angle. Hold on one second. There we go. Okay. So given a trig angle of 252 degrees, I want you to find the bearing angle, the reference angle, and the north-south angle, east-west form of the angle. So a 252 degree trig angle is going to be down here in the third quadrant, where this angle here is 252 degrees. If that trig angle is 252 degrees, then this reference angle here would be 72 degrees. If that's 72 degrees, then this angle here would be 198 degrees. That would be my bearing angle. And this angle here would be 18 degrees, which would be south 18 degrees west. Questions on those three? Okay. You will have a formative that will include vectors and bearing angles and navigation angles and all of that stuff this week, Friday, the day after tomorrow. Okay. Okay. So, from yesterday, we talked a little bit about the magnitude of a vector. Okay? So we've got vector v, and it's got the component form of x comma y. And then we talked about the magnitude of that vector, and the magnitude of v then would be x squared plus y squared, and then we take the square root of that sum. Okay? So we square the horizontal component, square the vertical component, add those two numbers together, and take the square root. That gets us the magnitude of the vector, which is also the length of that vector. Okay? Then we also said that the direction angle, we use the reference angles. So the reference angle for vector v would be the inverse tangent of y divided by x, and we always drop any and all negative signs in there. Then depending upon which quadrant your vector is in, and remember the quadrant that your vector is in is based off of the positivity of x and y. Okay? Just like if it were a point, positive is in quadrant 1, negative is in quadrant 2, negative is in quadrant 3, positive is in quadrant 4. So depending upon the positivity there, if you are in quadrant number 1, then actual direction angle is equal to reference angle. If you are in quadrant number 2, actual direction angle is 180 degrees minus the reference angle. If you're in quadrant number 3, actual direction angle is 180 degrees plus your reference angle. And if you're in quadrant 4, actual direction angle is 360 minus your reference angle. Okay? And those haven't changed since you learned them in semester 1. Questions on any of that? Okay? With that being said from yesterday, let's put it to work. Here is vector u. Vector u has the component form of 1 comma negative square root 3. I want you to find me the magnitude of u and the direction angle of u. Okay? Try it. I get the magnitude of u is 2. So the direction angle, or the reference angle, I should say, is the inverse tangent of the square root of 3. Inverse tangent of the square root of 3 is 60 degrees. What quadrant is vector u in? It's in quadrant 4. So therefore, actual directional angle is 360 degrees minus my reference angle. My reference angle was 60 degrees. So actual direction angle for vector u, I put vector v there for a second. Oops, come on now. Is 300 degrees. Questions, comments, concerns, clarifications? Okay. So in vector v here, we have its magnitude, we have its direction angle, we need to find vector v in component form. Okay. So vector v is going to go out that direction, because this is then would be 135 degrees. We know that vector v is 6 units long. We need to find v in component form. Well, vector v in component form is going to have some horizontal and some vertical part, right? How can I get a horizontal out of that and a vertical out of that? I don't have a triangle. Make one, right? Make one, right? Okay. All right, let's make a triangle. So we can go there. We can go there, right? Okay, now we can use a little SOHCAHTOA. All right, what do I know about this angle right there? What do I know about that pink angle? 45 degrees, yep. Yeah. So what's x going to be? How am I going to find x using SOHCAHTOA?
Wait, why do you have to use SOHCAHTOA? Can't you use 45, 45, 90?
You'll see why in a minute. Yep. 100%. 100% you could use the special right triangle. 1000% you could. Get the same answer. But I want to do it this way because of where we're going. Okay? All right? For x? Cosine. So the cosine of 45 is going to be x over 6. So x is going to be 6 cosine of 45. Yes? Okay. Cosine at 45 degrees is 2 over 2, correct? So x then is going to be 3 square roots of 2. Yes? Does that fit, though? Does that work? Would this be 3 square roots of 2 right there is my question. Albert? Why is it going to be negative? Because it's in quadrant 2. It's on the left side, right? So we have to make an adjustment here. We got to make that be negative to fit where the vector goes. Okay? All right, I like it. And then y would be the sine of 45 degrees. So y would be 6 sines of 45 degrees, which would be also 3 square roots of 2, because the sine of 45 is the same as the cosine of 45. Would this fit in here? Yeah? Okay. So let's look back here at these two, at this line right here. Where did the 6 come from? Magnitude. The 45 came from the direction angle, right? But it's the reference angle, correct? Okay. So is there a way that we can adjust that to fit with the direction angle? And the answer is yes. Okay? So that if you have given the magnitude of u and the direction angle of u, vector u in component form is the magnitude of u times the cosine of the direction angle, comma, the magnitude of u times the sine of the direction angle. And therefore, you don't have to, as Albert did before, adjust, because it will automatically adjust for you. If you use the trig angle, it automatically adjusts for you. Puts it in the right quadrant. Okay? This one is going to be very important for you going forward. Okay? You will need to memorize that one. Okay? You will use that in the next 2 weeks. You will use that probably 75 to 100 times. Okay? Alright? Yes, sir.
Oh, once you find once you have two of the things, can't you just do the factorization here?
Once you find one of them? Yeah. Yeah, because you were given one, you found one. Yep, by all means you could do that too. Okay? But this will work all of the time. Okay? Alright? And you don't have to do any calculations. You don't have to draw an extra triangle. You can just go right to it. Okay? So vector v here, oops, would be negative 3 square roots of 2, comma, 3 square roots of 2. Okay? You try one now. Given vector v, find me magnitude and direction angle. I get a magnitude of 5 and a direction angle of 233.130 degrees. Yes, no, maybe. Yeah? Questions? Okay. First semester, we talked about the unit circle. Okay? And we've used the unit circle many, many times since then. What makes the unit circle the unit circle? Radius is 1, so it's a circle with radius 1. Okay? We are now going to talk about some special unit vectors. Okay? So if the unit circle is a circle with radius 1, what is a unit vector? It's a vector with a magnitude of 1, right? Okay? So can you come up with a vector with a magnitude of 1? Give me a vector with a magnitude of 1. Gotta have a magnitude of 1. Give me a vector, and I'll tell you if it's a magnitude of 1.
Parentheses 1, comma 1, parentheses.
1 comma 1 is not a unit vector because it's got a magnitude of the square root of 2.
Oh, yeah.
What?
1/2 and 1/2.
1/2 and 1/2 would be 1/4 plus 1/4 is 1/2. Square root of 1/2 is root 2 over 2. Magnitude not 1.
Not possible.
It is 100% possible. I can think of 4 of them right off the top of my head. Enzo.
Root 2 over 2, root 2 over 2.
Root 2 over 2, root 2 over 2 is 1. Okay? Alright? That is one of them. Yes. Not the specialist of the special ones, though. But yes, that is a unit vector. Putting in vector form? Yep. Okay, now give me the special ones. Give me, let me change special. Give me the 2 easiest ones. 1 comma 0. We're going to call that vector I. Yeah. What's the other easy one? Say it louder. 0 comma 1. We're going to call that vector J. Okay. Those are special vectors because now we can rename any vector using the linear combination of I and J. Ooh, my E was really bad. Like, really bad. I don't even know what that is. I don't know why it's glitching all of a sudden. Okay? It's another way to write a vector. Okay? Now, you won't use this a lot, but we are giving you an introduction to it. The higher you go in math, the more you'll use I and J forms of vectors. Okay? Alright? But any vector can be written as a linear combination of I and J. So if I take vector v, which we just found the magnitude of vector v, and we just found the direction angle of vector v. This was the one that we just did. I can say that vector v here, which has a component form of -3, -4, is also can be written as -3i minus 4j. And here's why. If I is the vector 1 comma 0, then this would be -3 times the vector 1 comma 0, which would be the vector -3 comma 0 from yesterday. Do we agree with that? Okay. Then I can say -4 times the vector j would be 0 comma 1 would be the vector 0 comma -4. And if I add vectors, what do I do with their horizontal components? Add them. What do I do with their vertical components? Add them. So then this becomes negative 3, negative 4. Okay? Super easy. If you have the component form of a vector, it's literally just the horizontal component, I, plus the vertical component, j. That's it. Okay? It's not anything more complicated than that. Okay? It's literally just horizontal component, I, plus vertical component, j. Okay? It's just another way of writing things because mathematicians hate writing these funky vector brackets. Okay? All right? So let me give you a supplemental one. Give me two numbers. And?
7.
I'll say literally you can't be wrong. I just need it to be a number. Okay? So if I got the vector 5, comma 7, that's the component form, yes? What would the linear combination of I and j form be?
5i
5i
minus 7j plus 7j.
plus 7j. Okay? That's it. Just another way. Now you got 2 different forms of vectors. Just like you got 4 different forms of angles. Okay? And we'll use them sporadically throughout. Okay? So, what we've learned so far in this 35 minutes of class today is that if we've got a vector v, and it is of the component form x, comma, y, then that is also the xi plus yj linear combination form. Okay? The x part of the component form would be the magnitude of v times the cosine of v's direction angle. The y component of the component form would be the magnitude of v times the sine of the direction angle of v. The magnitude of v is going to be x squared plus y squared, and then we take the square root of it. And our reference angle is going to be the inverse tangent of y over x, and we're going to drop any negative signs. Okay? Everybody good? All right. So here's the magnitude of u. Here's u's direction angle. Here's the magnitude of v. And here's v's direction angle. Okay? We want to find the vector u plus v in component form. We want to find the magnitude of vector u plus v. And we want to find the direction angle of vector u plus v. Okay? Well, can I find the component form of just vector u? what's it going to be? What's the component form of vector u? What's the horizontal component going to be? The x part, if you will, from the last slide.
2 commas 2 times
Keep going. And right? Because x, the horizontal component, is the magnitude times the cosine of the direction angle. Y, the vertical component, is the magnitude times the sine of the direction angle. Agree? Okay. What is the cosine at 30? Or what is cosine of 30 degrees? Root 3 over 2. What is root 3 over 2 times 2? What is the sine at 30 degrees? Times 2? 1. So the component form of u is root 3 comma 1. With me so far? Okay. Now let's find the component form of v. What's the horizontal component going to be? 3 cosines 90. Vertical? Cosine at 90 degrees
0,
times 3.
0,
Sine at 90 degrees
1,
times 3. What is the component form of vector u plus vector v?
square root of 3 plus 4.
Comma 4?
Yeah.
Which would be I square roots of 3 plus 4j if we were asking for it in linear combination form. Okay? But we only asked for it in component form. I just didn't want to totally go away from it right away. Yes, ma'am?
Why do you have the square root of 3 behind the I?
Because then it doesn't look like the I is inside the square root of 3.
Solid.
I always put my square roots last. With me? Okay. Now we can find the magnitude of u plus v. So that's going to be the square root of 3 squared plus 4 squared, and then take the square root of that. Square root of 3 squared is 3. 4 squared is 16. So the magnitude of u plus v is going to be the square root of 19. The direction angle of u, which quadrant is u plus v in? It's in quadrant 1. So the direction angle is actual, or is the reference angle. Okay. So this is just straight up the inverse tangent of 4 divided by the square root of 3. And the inverse tangent of 4 divided by the square root of 3 is 66.58678 degrees. Agreed? Questions on that one? You try this one now. Same style of problem. So I get vector u is negative 25. So u plus v then. It's going to be oops. Sorry, 3 decimal places. Final answer. If I wanted this one in linear combination form, it would be 6.721i plus 58.093j. Okay. We're in quadrant 1, so we can go directly to the direction angle. We don't have to find the reference angle. So then this would be the inverse tangent of and again, I'm leaving all of these on my calculator as full decimals, not rounding them yet. So then that gives me my reference angle, or excuse me, my direction angle of u plus v to be 83.401 degrees. Agree? Okay. You will have a formative on Friday that includes all of navigations and vectors and all that fun stuff. Okay?
I mean, it's only
Huh?
Yeah, I needed a.
You have enough information now to do 1 through 17 in your homework packet.